Thank you, Mr. Chairman. It's a pleasure to be here in Dortmund. This is actually I just calculated that my fourth time in this conference, and I must say that this has been one of the top conferences in all the years. I'm looking forward to have one more experience here. As you can see, my name is last of the authors. We all know what that means. It means that if you have positive feedback, you can tell me. If you have negative feedback on presentation of the paper, you can ask me about my colleagues' email addresses and address that feedback directly to them. The topic of our paper was already stated, the decentralized approach to logistics execution monitoring in multi-actor network. It is actually based on the research that we have been doing in the framework program 7, one project there within the VTT, and also some experience that we have in domestic research projects that has been done for the customers. A little bit about the content itself. I'm gonna quickly go through the background of the research. And as this is a scientific session, it's always a pleasure for scientists to say something about research design, meaning the methodological side of the research. Then going through a little bit about the interorganizational information systems, current ones in logistics, as well as the business information exchange systems. We finally go through some of the case study results that we had on FP7 project called eFreight, where VTT was one of the partners, also some experiences that we have had in different other projects. And finally some conclusions. So, as we all know, the effective logistics and supply chain management requires a sharing of knowledge. As it also in the name of this conference, we need to share that information within the supply chain with different partners and supplier network as well with the customers. Of course, the ICT plays a big role here, how to make this information exchange more efficient, and based on the previous research, it's quite obvious to say that ICT is one of the enablers of the cost savings as well as improved service level and also the control of the whole supply chain and business processes of the companies. So how we want to see that is that we are not just thinking about ICT as a technology, but also how it can change the processes within the supply chain. Currently, the most ICT solutions are centralized. Usually these are provided by logistics service provider and based on their company systems, meaning that they are the driver of the ICT implementation projects. Unfortunately, it cannot be said that one size fits all to this perspective and this domain, meaning that necessarily these systems that are made by logistics service provider are the most or the best ones in all the situations. So far, the research hasn't paid that much attention to alternative ways of arranging information exchange in supply chain. This is why we have participated on projects that also studies decentralized systems of doing that. Not only by the way that one is implementing the system and everyone is using that, but how this information can be produced and shared in decentralized distribution network as well. In this paper, we present so-called forwarder independent monitoring system, or actually the concept of that one. We also, I'm also going to say a few words about the project the eFreight project that tried to and actually develop this kind of system. But in the conceptual level, we try to sort of like see the system in a way that how this information exchange could be organized in decentralized way, covering all modes and stakeholders. We also try to look at the benefits of this kind of approach. And as we all know, it's really highly ranked in the EU's agenda as well to have different kind of synchromodality, multimodality. So how these kind of information exchange solutions can support that kind of development that we are employing the combination of different transport modes. So about research design, if we want to characterize this research in one way, as I mentioned, this is sort of like a mix of different researches, and this is the actual results are based on case study. But if you want to see this research as from a methodological point of view, this could be the action research with constructive approach, meaning that the researchers have been part of developing the solution, testing the solution, and validating the solution. In general, the steps of the constructive research that are agreed on the previous literature is first finding a practical relevant problem. In this case, it has been the sort of like the weaknesses of the centralized systems. So we try to see what are the reasons that we should have different options with this decentralized system. The second step is to obtain a general and comprehensive understanding of the topic. Of course, this is something that we do in research all the time. We follow the findings of the other researchers, we follow what is going on in the industry. We participate in research projects, so that's why we should have a comprehensive understanding on the topic. The next one is, of course, to come up with an idea that is better than existing solutions. And in the IFRED project, we were part of the project consortium that introduced a new system and framework of doing information exchange. The solution was demonstrated in the cases, and of course, then we also, at that point, we also created new knowledge and theoretical point of view. And of course, the feedback of the cases, the evaluation is one important part of every research project. So if you want to see a little bit like what is, how the information systems or the information exchange systems are used in logistics. As I mentioned already, that in order to supply chain to work efficiently, we need to exchange information with different partners. We also need to share the information within the company in a closed, sort of like closed cycle, but we also need to work within the network. There are different ways to identify different implementation stages in the framework of logistics or the information framework for logistics. Some companies, I would say in Finland still many companies, they are sort of like in a pre-supply chain phase that not much information is exchanged, not at least in the standardized electronic way. If you take, for example, some figures, the share of electric transport orders in Finland, or the share of the transport orders that have been made in electronic way is around 35 to 45%. So all the other transport orders have been made by telephone or other email or other ways, but in this kind of like standardized ways, it's only around 40%. The second stage is sort of functional orientation, so ICT is implemented, for example, for warehousing management systems, in one function in the organization or the business. The third one is internally integrated, which means that different functions within one company, they are communicating each other in standardized and electronic way. The next one is external integration of ICT implementation, which means that companies may have bilateral agreements how they exchange the information with ICT solutions. The last one is sort of like the largest or the final state of the ICT implementation, meaning that the whole value chain has integrated with ICT systems and all the information is exchanged electronic way in the whole value network. Some of the roles that could be identified in decentralized system, these are based on the eFreight project. So the transport user, the one who is actually buying the transport, who needs the transportation services. Transport service provider, who is providing the service for the user. The network manager, which is also can be, for example, authority, transport agency that is managing the network, and the regulator. Here we come, for example, cross-border transport. There's customs, for example, that need to have some information of your transportation when it crosses borders. Currently, there are already initiatives and information exchanges systems in field of logistics. The sort of like the starting point is that the transport document is mandatory to follow the carriage of goods, meaning that, for example, when you're transporting goods by road, you need to have a way bill and a list of goods that are transported in the truck. We studied a little bit the Finnish legislation in this sense, and the legislation itself doesn't say that you need to have the paper document in the car or the truck. But you need to have access to, for example, information system that you can get the same information that should be on a way bill at a place. So you need to have some kind of device that you can prove what is in the cargo. We already discussed earlier about the different transportation modes that use different documents. To mention a few, we have already in road freight transport the ECMR e-way bill is introduced. Concerning the rail freight transport, there are telematic application for freight framework introduced. In air transport, the International Air Transport Association has introduced their own e-freight system that actually has quite extensive penetration rate in the field of air transport. Of course, the air transport market itself is quite closed, and that's why they have organizations that can actually push these kind of new ways of doing things quite heavily. When it comes to waterborne transport, there are International Maritime Committee has published the rules for electronic bills of lading. We have different systems that you can declare your transportation information, for example, SafeSeaNet, PortNet in Finland, and river and vessel traffic management information system. These are just some examples that we already have there, but sort of like to present the field that we need to work, that we have still a quite solid distinction between the different transportation modes. So when we're talking about multimodality, synchromodality, co-modality, we need to sort of understand that if we want to push electronic information exchange, we need to comply with quite many different issues. So I guess many of us know that electronic data interchange means structured transmission of data, allowing transfer of electronic documents between computers based on electronic messaging frameworks. To do that, of course, we need to agree on standards for message formats and protocols. We have different standardization organizations. based on, for example, UN standards. We have some national standards, we have some area standards, and we also have industrial standards for different industries. And not all of these actually can comply with each other. In recent years, the extended markup language XML has, of course, gained ground as a format of messages. Coming to the EU situation, the Commission or the EU has quite heavily promoted adoption of single transport document and single window, meaning that you can declare all the information to different parties, whether they are authorities, whether they are port operators. You can declare this information via a single window. The single transport document should cover all the transportation modes. And of course, the Internet of Things is one big topic that EU has also promoted quite much, with the industry, of course. Some of the electronic information exchange things or initiatives in EU or European Commission have published a vision about the e-freight initiative. I also noticed that we have quite much program or presentations tomorrow and the day after related to this e-freight thing, so I'm not going to get any further on that. There was also a project called e-freight in FP7, which ran from 2011 to 2014, and we can see some of the results of that project here. In the e-freight project, there was 8 transportation documents which were also presented in XML messaging framework format was identified. The transport service description, which was basically the first step that transport logistics service provider, as you can see in the picture, provided to client or the user of transportation services. Execution plan, which was basically the negotiation between the logistics service client or logistics service user and logistics service provider. Goods item itinerary was basically the list of goods and the attributes. Transport status, now we actually come to the situation where this information during the transport needs to be transmitted between the user and the provider. Single transport document, which was also sort of like waybill between the user and the provider, which identified the goods in transport. Common reporting schema as well as security data message was more like regulatory and authorities point of view messages. And all of these messages were in the project were standardized in OASIS Universal Business Language 2.1 standard. One of the key points of the project were the e-freight access points, which basically were the connection points for different parties of the supply chain to communicate between each other, so they didn't need any bilateral agreements on the message format and framework. Rather, these access points were the kind of like places where the information was entered the system and where it was possible to obtain the information. So as I mentioned, one of the benefits was that there was no need for external communication link between the provider and user, and different stakeholders, if you will, in supply chain could access the information by connecting these access points. So if you talk about the monitoring solution, like how we should be able to monitor the actual transportation process, from the logistics service provider perspective, of course, we willing to know about the location of the transport, location of the handling unit, meaning where the truck is moving, where the handling unit is when it's, for example, in warehouse or cross-docking center, monitoring the condition, humidity, temperature, for example, which is quite crucial, for example, when it comes to grocery goods or medicine or other these kind of things that are need to have certain temperature or certain circumstances also during the transportation. Also the security issues, whether the container is breached or not, recording the status of the transport per consignment, when there's deviation, how to manage those. For example, updating ETA, estimated time of arrival, is one of the information on that sense. And also reporting the handling unit status and also some KPIs for improving the whole service. So from the customer perspective, of course, they are willing to know where their goods are at the moment and what is the status of the consignment. I would be more than willing to know where's my suitcase, which was lost by Aeroflot 2 days ago. So I certainly hope that Aeroflot is also going to take this kind of framework, because obviously the current situation is that Aeroflot says that it has been left from Moscow, and the Helsinki airport officials say that it has never been in Helsinki. I'm sure this has something to do with the current political situation, but if it's so, I guess I'm sort of like, I should lose my hope. Of course, only with the luggages. So we had one case that we want to present here related to the e-freight project, which was the ACOS logistics service provider, and the purpose of the case was to see how this monitoring application could be implemented in existing systems. So the goal was to introduce new messaging framework and this access point concept to existing ACOS software that they have, both for their own purposes as well as client purposes. So they currently had or have the system that consists of 3 parts: the desktop software that supports tasks like order management, scheduling, dispatching processes, and transport operations, controlling the online software that customer can actually monitor the transportation and also make some calculations related to that, and fleet management and telematic system that enables connection between the car and the service provider. The functions that were used in the business case covered booking, planning, and monitoring, so basically the whole chain. Some of the research results that came out of this business case, based on the user experience, time savings, and improved data quality, made the operation of process more flexible in the planning-wise. Also, the whole business process was more transparent after utilizing this decentralized network, fewer errors due to automation, and also the overall better planning and schedule of the status updates, for example. So, in one word, more transparent processes. Some numbers related to time savings based on this same case study. The electronic orders actually saved 1,100 hours of booking work. Updating ETA and other planning related information saved another 6,500 hours of working time, and the structured and harmonized data collection from the transport status data made also time savings of 3,500 hours. So together, by implementing this kind of decentralized information exchange framework, it was possible to make more than 20,000 hours of time savings. So we can imagine that that's actually something that has impact on companies' performance. So some conclusions. The complexity of supply chains today require more sophisticated information sharing solutions. Of course, there are things that not all the companies want to sort of like open their books for everyone. So that's why we need to have a system that allows different parties of supply chain to have that information, what is most needed, but not sort of like sensitive information. The transport more specific documents pose some challenges, how to tackle that one. The single transport document and single window by European EU is one way to do that. The better availability of data creates better opportunities for supply chain integration. This forward independent approach or decentralized approach is one way to meet or tackle these challenges. And the novelty of this solution lied in creating a new communication network between the user and provider of transport services. And as I mentioned, this framework, developing this e-freight project was standardized in XML-based UPL 2.1 standard. And as the last slide showed, some of the results were all validated in business case. Of course, it's one case, and these benefits need to be considered by case, but there are some examples that show that this kind of system can also work. So, thank you.